Advances in aviation history give way to legendary aircraft that become the most powerful and innovative weapons of our time. Each airframe is unique, with limitless capabilities. But one thing remains the same. Underneath the surface, they are all simply great planes. It was the world's first fighter with independent search and destroy capabilities. Capable of flying at more than twice the speed of sound. Simultaneously flown by Blue Angels and Air Force Thunderbirds.
The McDonnell Douglas F-4 Phantom starts out as a carrier-borne fighter, but it soon develops into one of the Western world's most successful land-based tactical aircraft. I'm Paul Max Moga, and we're here at the Hampton Air Power Park in Hampton, Virginia. Join me as we hear the story of the F-4 Phantom. McDonnell Douglas builds more than 5,200 Phantoms, and the F-4 still serves with the U.S. forces and 10 other countries.
Who better to help us tell this extraordinary story than a highly experienced Phantom crew?
Lanny, Cucho, it is a
Max, how you doing?
pleasure to have a couple of old warriors around to talk about the Double Ugly. Lanny, give me just a quick rundown of how much time and experience you got in the old F-4.
I got about 900 hours in the F-4, about almost 700 of which is combat time.
Wow.
And started flying it in very early 71, flew it through 72. Then I had a headquarters hiatus for about 9 years, and then flew it again at Nellis for a while before converting to the F-16.
How about you, Cucho?
Well, I flew the F-4 straight out of a navigator training. I've spent 1,350 hours in the F-4, 9 years.
She must have took pretty good care of you.
Oh, she did. She's a really nice airplane.
The Phantom story begins in the early 1950s as the McDonnell Douglas AH-1, a twin-engine supersonic attack aircraft.
From its inception, the project was designed around the most powerful jet engine available at the time. The General Electric J-79 design promises a top speed of Mach 1.97, or almost twice the speed of sound. The company begins work in 1951 to produce the new axial flow engine with low weight and great fuel economy at Mach 0.9, but with the strength and thrust for Mach 2 performance. The J-79's radical design includes a variable stator compressor with adjustable blades and the afterburning exhaust nozzle. Variable stator vanes allow the engine to perform at its peak at all altitudes. They would become a standard feature of military engines in years to come. The design provides a 2/3 increase in thrust. During testing in August 1953, it worked so well that the test crew thinks the instrumentation is faulty. GE connects a J-73 turbojet afterburner to the J-79, creating a new engine in 1954. The radical new engine takes to the air in May 1955. Installed in a nacelle that can be extended below the belly of a converted North American B-45 bomber. Once the B-45 is airborne, the J-79's initial test runs confirm the engine's basic capabilities in steady, level flight. Then comes a series of air starts, crucial for any jet engine. The J-79 passes its test with flying colors, hitting 13,000 pounds of afterburning thrust. The first flight-qualified J-79 ships off to Edwards Air Force Base in California for more ground and flight tests.
I would think, Cuccio, that one of the reasons the F-4 has two engines was because it was designed as a Navy plane. And Navy guys, if you're going out and back to a boat, probably want to have more than one motor. But that's just me guessing. Talk to me a little bit about the engine. I mean, I'm looking at that burner can right there, and it's not small.
No.
So these things were a pretty crucial part of getting the lead sled into the air.
Well, the J-79 was originally used in the B-58 and also in the F-104. And it's an amazing engine. It usually didn't fail us. Mm-hmm. But in case, like you said, in case that one failed, we always had something to fall back on and bring it back home safely.
Fuel, oil, and 100 or more electrical connection checks all pass inspection. The XF-4D1 prototype, or Skyray High Performance Naval Interceptor, is chosen as a test bed for the new engine. Ground runs in idle and afterburning thrust test the basic installation. On December 8, 1955, the J-79 equipped test aircraft readies for its first flight. Nicknames for the Phantom II include Rhino, Double Ugly, Flying Anvil, and Lead Sled. In December of 1955, GE tests its new J-79-powered Skyray prototype. The aircraft takes off downwind to make full use of the runway, eating up about 6 miles of the famous dry lake bed at Edwards Air Force Base. The flight climbs to 18,000 feet before returning for a landing. With the tests a success, the J-79 is cleared for operational service. Although the engine is a success, McDonnell Douglas's plans for a new naval attack aircraft are not. Instead, the Navy asks for an all-weather fleet defense interceptor. The new aircraft is called the F-4H-1. It's given Mach 2 plus performance, and the primary armament gets upgraded from 4 20mm cannons to 4 Sparrow air-to-air missiles. A powerful search and fire control radar make the F-4H the world's first fighter with self-contained search and destroy capability. In 1958, the XF-4H-1 prototype rolls out at Lambert Field, St. Louis. The test pilot, Bob Little, hopes to take it supersonic, but there's a small hitch.
Our intention on that flight was to take the airplane supersonic on its first flight. We had done that 4 years before in the F-101, and it was certainly something to be accomplished in the F-4. It didn't work out that way. Landing gear didn't come all the way up, and on that flight, a hydraulic system failed on takeoff, so had to bring the airplane in after about 20 minutes of learning how to fly it well enough so I could land it.
The XF-4H-1 eventually taxis into position on the runway, and everyone agrees that McDonnell Douglas has another design winner despite the maiden flight difficulties. The F-4H1 incorporates many unique features that will ultimately appeal to the Air Force as well as the Navy. The pilot sits in the front seat. The radar officer behind him can use a blind to darken his cockpit for viewing the radar screen. The cockpit has no shortage of displays and controls. Crew members sit on Martin Baker Mark V ejection seats. They can safely eject at 0 altitude and at speeds as slow as 150 miles per hour. The crewman initiates ejection by pulling the overhead handle while the blind protects his face.
Tell me a little bit about the ejection seat, Lanny. It's an old Martin Baker.
It's an old Martin Baker seat. Was very interesting to get into and out of under normal circumstances. Now, if you ejected, it was all automatic, and it kept your legs from flailing, which at very high speed could save your life. So it was a good seat. And of course, you could also, under emergency situations, eject on the ground.
You grab both the rings and you just pull them down.
You have two methods. Yeah, the over the head, which it pulls a screen in front of your face, is probably preferable, especially for high-speed ejection. But the issue there is, are you able to hold on?
Yeah.
With the forces at high speeds? I think you probably would not be able to, but it's better than nothing. But I actually never even practiced that. I always use the D-ring between my legs. Much quicker to get to. Much quicker to get to. Stick, ejection seat.
Two fully variable inlet ramps help the J-79 engines reach Mach 2. A splitter plate diverts the boundary layer of slow-moving air close to the fuselage. And the inlet ramp jackknifes out at speeds over Mach 1.4 to control the shock wave and maintain an even flow of air at the face of the engine. The aircraft's data computer controls this fully automatic system. On the port side of the fuselage, a pneumatically extended ram air turbine generates emergency power if the engine fails. Down to a speed of 225 miles per hour, the turbine provides electrical power, then switches to hydraulic power for the landing systems. Four pylons under the wings supplement the centerline hardpoint for carrying stores. On the leading edges of the wings, three-section slats maintain an even airflow and reduce stalling speed.
All right, Cucho and Lanny, this is a pretty unique-looking wing to me. I mean, the tip is canted up. Cucho, was it always like that? I mean, or was it ever a different design?
Well, the Air Force model was always like that, but remember, we got the airplane from the original design from the Navy. Well, when it was originally the prototype, one of the original prototypes had straight wings, but because of stability problems, the designers decided to try to put dihedral, and this is what this is. And the dihedral corrected a lot of the stability problems.
The airframe has two trailing edge flaps. Slots blow air from the engines over the upper surface of the flap to control the airflow and maximize the effect of these fairly small surfaces. Landing requires the full flap setting. Takeoff requires half flaps. Spoilers and ailerons provide lateral control. The underside of each wing sports a hydraulically operated speed brake to provide rapid deceleration from its top speed of Mach 2.4. The plane can land safely with the speed brakes extended. The long, low vertical tail of the naval variants fits the low headroom of U.S. carrier hangar decks. Under the rudder is the vent for the 6 fuel tanks located in the fuselage. The aircraft also had the ability to carry 3 drop tanks. The horizontal slabs ensure full pitch control under all flight conditions. Their 23-degree angle improves directional control by increasing the effective side area of the rear fuselage. Between the J-79 tailpipes is the arrestor hook, normally stowed under the rear fuselage fairing but extended for carrier landings. On land-based Phantoms, the hook helps short landings on runways fitted with the appropriate arresting gear. Navy and Air Force Phantoms generally have different tires, but of the same diameter. The broader Air Force tires offer greater touchdown area and are inflated to lower pressures suitable for longer, land-based runways. In the rear fuselage, stainless steel, titanium, and ram air cooling provide heat resistance. A compartment at the tail end holds the 16-foot braking parachute, needed to shorten landing roll on ordinary runways. The hole in the tail expels the air drawn in to cool the engines. The Phantom looks like no other plane. One of its most distinctive features, the power-folding wings, reduces the Phantom's width on carrier decks and elevators. On land-based Phantoms, the folded wing gives access to the boundary layer control system's plumbing. The large nose radome accommodates the 32-inch diameter antenna of the APQ-72 main radar. Under the nose, the fairing for the infrared scanner provides backup if the main radar malfunctions or gets jammed. With a crew of 2, a powerful radar, and a combination of Sparrow medium-range and Sidewinder short-range missiles, the Phantom is the world's first fighter with search and destroy capability independent of ground control. From the start, the new Phantom is a record setter. The Phantom II is the first aircraft to fly concurrently with the U.S. Navy, Air Force, and Marine Corps. In December 1959, the Phantom sets a zoom climb to altitude record of 98,556 feet. In September 1960, it takes 2 closed circuit records of 1,217 and 1,390 miles per hour. Less than a year later, in August 1961, it sets a low altitude speed record of 903 miles per hour. Followed by an absolute world speed record of 1,606 miles per hour. But perhaps the most spectacular of these early achievements comes in May 1961, to mark the 50th anniversary of naval aviation. 5 prototype Phantoms fly west to east across the U.S. in 2 hours, 47 minutes, shattering the previous best. F-4Bs assigned to the USS Forrestal Battle Group become the Atlantic Fleet's first Phantom unit. and they immediately fit into combat operations. Each mission begins with a briefing and survival gear issue before the crews don their life support equipment. On the command of flight operations, the crews proceed to their aircraft. Meanwhile, the deck crews, each wearing color-coded vests for identification, finish their preparations for the launch. The pilot completes his walk-around check of the aircraft. Then he and his radar officer board the Phantom. Launch weight is chalked up for the catapult officer's attention. Fleet defense requires the pilot to fly the aircraft and execute any tactics, while the radar intercept officer operates the radar and controls the early stages of any engagement. The flight deck director positions each aircraft over its designated catapult. And the aircraft is eased over the shuttle and onto the rear section of the catapult where the bridle is attached. All is ready for launch as the deck crew scrambles out of the way. The deck director signals the pilot to push up his power for takeoff. Finally, the director signals the launch, and the Phantom hurls down the catapult run and over the bow of the carrier at 185 miles per hour. As the first two depart on their combat air patrol, another pair of Phantoms taxi up for launch. The launch sequence continues, dispatching up to 4 aircraft simultaneously. At the end of the patrol, the Phantoms return to the carrier. As they approach at 150 miles per hour, each aircraft gets a visual check to ensure the landing gear and flaps have lowered. Once the deck is clear, the landing signal officer talks the plane down.
Okay on 3. Highest ramp on 5.
As the pilot lines up his approach, an amber light, called the meatball, guides him in. The pilot lines up with the row of green lights to ensure that he's in the proper lane so he can catch the wire. After the landing, the wire is disengaged from the arrestor hook and returned to its position, ready for the next plane. Before their next mission, the aircraft head down to the hangar deck for maintenance. Throughout the 1960s and early 1970s, the Phantom F-4B and the upgraded, more powerful F-4J versions provide the U.S. Navy's first line of air defense. The Phantom provides unbeatable combat air patrol within a 400-mile radius. During the Vietnam War, U.S. Navy Phantoms sometimes operate as attack aircraft from land bases. They are primarily F-4J aircraft evolved from the initial F-4B, with more powerful engines and drooping ailerons to supplement the flaps. A combination of the AWG-10 fire control radar and the AJB-7 bombing system give the Phantom the edge in air-to-air and air-to-ground combat. It is a combination that will be put to the test over the skies of Vietnam. Navy Phantom F-4Js proved themselves worthy in both land and sea-based attacks. In the backseat, the radar intercept officer monitors the tactical situation on his increasingly sophisticated equipment and keeps the pilot advised of the current situation. The Phantom was initiated in Vietnam and was one of the few U.S. combat aircraft to stay in that theater. Throughout the war, it meets all its demands and is loved by its crews. But one of the early Phantom's shortcomings is a smoky power plant, which signals its location during an attack. Ten U.S. Marine Corps squadrons also operated the Phantom in ground attack missions in South Vietnam. Before strapping into the Phantom, the crew completes the standard walk-around checks to spot defects. The underwing pods get checked for full attachment, complete loading, proper electrical connection, and any flaws of the 2.75-inch rockets. The main landing gear wheel well gets checked for hydraulic or fuel leaks. A quick look assures that the Mark IV 20mm cannon pod is loaded with ammunition and ready to fire. The ordnance crew loads high explosive bombs onto the wing pylons. They insert flagged safety pins before removing the trolley. A safety wire fitted on each bomb prevents its arming until after it has been dropped. As it falls, the wire breaks, freeing the nose-mounted propeller to turn the requisite number of times to arm the weapon. The two crew members complete the standard walk-around check and climb into the jet. All moving surfaces get looked over one last time as the ground crew removes flagged pins and safeties. Loaded with 12 bombs and a centerline drop tank, the F-4B of Marine Fighter Attack Squadron 115 taxis out for takeoff. Other Phantoms slated for the mission join up on the runway. Before clearing for takeoff, the crew confirms that the outer wings have been locked down. They depart for another tactical sortie to support Marine Corps ground forces. During the late 1960s, the steadily increasing scope of U.S. operations in Vietnam demands that aircraft bases be upgraded to accommodate aircraft such as the Phantom, which requires fully paved runways. The success of Marine Corps ground forces in Vietnam depends on the fast response of their Phantom Squadron. Ground operations require all-weather, round-the-clock support. The Phantom pilots pride themselves on accurately delivering ordnance in a safe manner close to friendly forces. Once ground forces radio the precise location of the enemy, the Phantoms zoom in and apply constant pressure. Successive waves of aircraft can deploy specific types of ordnance for each tactical situation. But it is the U.S. Air Force that flies most of the Phantoms in Vietnam. They start with the F-4C, a land-based version of the F-4B, and then the modestly improved F-4D with enhanced ground attack capability. Although vulnerable to communist guerrilla attack, the centralized fueling system, such as this at Cam Ranh Bay, simplifies tactical operations. The Phantom's high fuel consumption makes it impractical to keep quick reaction units on the runway, but it's the only way the Air Force can deliver maximum firepower at a moment's notice. Under the scorching tropical sun, crews risk heat fatigue as they stand by in their idling aircraft. But in Vietnam, heat stroke is the least of their worries. There are currently 631 active Phantoms in non-U.S. service. U.S. Air Force F-4C Phantoms sit at the ready for attack in Vietnam. Flying with reduced fuel to allow the maximum 16,000 pounds of munitions, Phantoms link up with a Boeing KC-135 tanker to top off their tanks and to increase their combat radius.
An incomparable attack aircraft in Vietnam, the Phantom's combination of weapons loadout, range, exceptional airframe strength, and avionics ensure that it finds and hits its mark with deadly accuracy.
The F-4 flies 4.5-hour sorties with an overall record of 280 air-to-air victories and the destruction of more than 200 anti-aircraft sites. Phantom deftly tackles heavily defended outcountry targets in North Vietnam. These targets include vital communication links, power plants, and strategic stockpiles, all fortified with anti-aircraft guns and missiles. Even in cloudy conditions, the Phantoms get through and release their weapons. The Vietnam War witnesses the U.S. Air Force's entire spectrum of tactical weapons, including all types of freefall and retarded high-explosive bombs. Retarded bombs allow the attacking aircraft to drop accurately at low level and get away before detonation.
The airplane had a tremendous capability to carry a myriad of ordnance. You could carry a 3,000-pound bomb where you see the fuel tank now, or you could
3,000.
3,000. There was no conventional ordnance that any fighter could carry that the F-4 could not carry. F-4 could carry everything made.
In addition to nuclear.
Phantoms also operate in tight patterns at medium altitudes, dropping their bombs on command to deliver maximum impact. Napalm becomes a particularly important weapon in the U.S. tactical effort during the Vietnam War. The initial F-4C develops into the F-4D, replacing the APQ-100 radar with the APQ-109A, and gaining the ASG-22 sight. Both models lack an internal gun, so they frequently carry a gun pod for air-to-air and air-to-surface missions. The pod features an external ram turbine to power the cannon, which restricts the aircraft to speeds below 400 miles per hour during the firing pass. That confines it to mainly air-to-ground attacks. Though useful, the Su-16A and the Su-23A self-powered version for the high-speed air-to-air role are less than perfect solutions to the Phantom's lack of an internal gun. The Phantom also operates with air-to-surface missiles, such as the 12,000-yard range bullpup. The main air-to-air loadout consists of the medium-range Sparrow and short-range Sidewinder. Initially, Vietnam doesn't see much air combat. But when the MiG fighters appear, they're generally downed. The F-4E, the definitive U.S. Air Force version, introduces an M61 Vulcan 20mm cannon in the lower nose, along with a smaller diameter APQ-120 radar, upgraded engines, a slotted horizontal tail, and maneuvering slats on the outer wing panels. Revisions include podded electronic countermeasures, such as this jammer pod carried in the front left Sparrow missile recess. The Phantom soon gains large export orders and rapidly becomes the West's most important tactical fighter. The Phantom operates in Australia, Greece, West Germany, Turkey, South Korea, Japan, Iran, Egypt, Israel, Spain, and the United Kingdom. The extraordinarily adaptable Phantom operates with a wide range of weapons on its 5 hardpoints. Unguided rockets are especially significant for area ground attack. 2.75-inch and more rarely 5-inch types are fired against soft battlefield targets such as troop concentrations, unarmored vehicles, and artillery positions. The Phantom can carry 4 Sparrows under the fuselage and 2 or 4 Sidewinders on underwing hardpoints for maximum flexibility in the air-to-air role. Any number of U.S. bomb types can get deployed in saturation or precision bombing against point and area targets. Cannon pods deliver devastation in the air-to-ground role. The 20mm is typical, though the planes can carry 30mm pods as well. The Phantom serves as the most important aircraft in the U.S. Navy and Air Force during the 1960s and early 70s. It also wins a position on the aerobatic demonstration teams of each service. The Navy's Blue Angels fly the F-4J. The Air Force Thunderbirds rely on the F-4E.
As the Western world's most extensively used combat aircraft since World War II, the F-4 Phantom has racked up some impressive production milestones. Over 5,000 F-4E Phantoms were produced for the U.S. and Allied Air Forces by the end of its 20-year service history. And as late as 1983, a conversion of the F-4Ns created the QF-4N variant, a pilotless drone that can simulate even the most sophisticated targets. Now out of production, but still an effective warplane, the Phantom isn't going away anytime soon.